Thompson's safety training concerning machine guarding. Crushed hands and arms, severed fingers, blindness. The list of possible machinery-related injuries is as long as it is horrifying. Safeguards are essential for protecting workers from needless and preventable injuries. A good rule to remember is any machine part, function, or process which may cause injury must be safeguarded. Where the operation of a machine can injure the operator or other workers, the hazard must be controlled or eliminated. Most accidents involving machinery occur from several common situations. A worker reaches into an unguarded area of a machine to clear debris, not using proper lockout/tagout procedures when servicing machinery and equipment, unauthorized persons performing maintenance or using machinery and equipment, and lastly, protection is compromised by missing or loose machine guards. Here are some points at which mechanical hazards occur. First, the point of operation. Second, all moving parts of machinery. These include flywheels, pulleys, belts, couplings, chains, cranks, gears, etc. Also, feed mechanisms and auxiliary parts of the machine. And finally, in-running nip points of the machine. These points must be guarded to prevent possible injury. Let's take a closer look at each of these hazardous areas. The first common hazard area is the point of operation. This is simply the point where work is performed on the material, such as cutting, shaping, boring, or forming of stock. The point of operation absolutely must be guarded. Rotating parts are a common form of moving machinery that represent very serious potential hazards and must be guarded. Here we see a rotating pulley with spokes and a projecting burr on the face of the pulley. Also, a rotating shaft and pulley with a projecting key and set screw. Finally, you see a rotating coupling with projecting bolt heads. All of these examples of moving parts represent potential hazards for two reasons. First, they move or spin, and secondly, each example has a projecting part that could easily injure an operator who contacted the moving part with his clothing or skin. The third area of concern for common mechanical hazards is in-running nip points. Each of these images represent an in-running nip point, or an area where the moving part assembly could easily injure an operator by pulling clothing, tools, or even body limbs into moving equipment. Each of these examples represent fairly common in-running nip points: rotating cylinders, a chain and a sprocket, a belt and pulley, and a rack and pinion. Look at each image and think about how the direction of the moving parts, denoted by the arrow, creates the in-running nip point. To control the hazards at points of operation, moving parts, and in-running nip points, machines must be equipped with safeguards. OSHA has several general requirements for safeguards. They must prevent the worker's body or clothing from contacting hazardous moving parts. Safeguards must be firmly secured to the machine and not easily removed. Also, the safeguards must ensure that no objects can fall into moving parts. Additionally, safeguards can create no new hazards. They must not have shear points, jagged edges, or unfinished surfaces. They cannot create interference. They must not prevent workers from performing the job quickly and comfortably. Finally, safeguards must allow for safe lubrication of machinery. If possible, you must be able to lubricate the machine without removing the safeguards. Quite a number of ways exist to provide machines with safeguards. Machines can have one or more types of guards, including fixed, interlocked, adjustable, or self-adjusting guards. Machines may be equipped with other safeguarding devices as well. These may be presence sensing, pullback, or restraint devices. They may also have safety controls or gates. Safeguards can be provided by worker location and distance, by automatic material feeding and ejection methods, or by other miscellaneous aids such as awareness barriers, protective shields, and hand-feeding tools. Each is designed to prevent workers from exposure to machine hazards. First is the fixed guard, which provides a barrier as a permanent or fixed part of the machine. The fixed guard is preferable to all other types of safeguards. As a general rule, a power transmission apparatus is best protected by fixed guards that enclose the danger area. However, for hazards at the point of operation where moving parts actually perform work on stock, several kinds of safeguarding are possible. An interlocked guard is a type of guard that, when opened or removed, signals a tripping mechanism that automatically shuts off or disengages the machine's power and does not allow the machine to cycle or be started until the guard is back in place. An interlocked guard may use electrical, mechanical, hydraulic, or pneumatic power, or any combination of these. Replacing the guard should not automatically restart the machine. The adjustable guard provides a barrier which may be adjusted to facilitate a variety of production operations. Adjustable guards are useful because they allow flexibility in accommodating various sizes of stock, but because they require adjusting, they are subject to human error. The adjustable guard on this bandsaw blade is a very common example. Self-adjusting guards provide a barrier which moves according to the size of the stock entering the danger area. Self-adjusting guards are considered a better method than adjustable guards because they avoid the potential for human error associated with the adjustable guards. A pullback device is a method of safeguarding that utilizes a series of cables attached to the operator's hands, wrists, and/or arms, and is primarily used on machines that have a stroking action. The pullback device allows access to the point of operation only when the slide or ram is in the up position. When the slide or ram begins to descend, the pullback device withdraws the operator's hands from the hazard area. Here's a further look at the pullback device. In the first image, the operator's hands are feeding stock into the die and the point of operation is exposed. The pullback device is attached to the operator's hands and properly adjusted. In the second image, the die is closed. When the operator closes the die, the pullback device withdraws his hands away from the hazardous point of operation. Similar to the pullback device, a restraint device uses cables or straps attached to the operator's hands and a fixed point. The device must be adjusted to let the operator's hands travel within a predetermined safe area. Hand-feeding tools are often necessary if the operation involves placing material into the danger area. Safety tripwire cables are a device located around the perimeter of or near the danger area. The operator of a machine equipped with tripwire cables must be able to reach the cable to stop the machine at all times. A two-hand control device requires constant and concurrent pressure to activate the machine. The operator's hands are required to be at a safe location on the control buttons and at a safe distance from the danger area while the machine completes its closing cycle. A gate is a movable barrier device which protects the operator at the point of operation before the machine cycle can be started. If the gate does not fully close, the machine will not function. Another potential application of this type of device is where the gate is a component of a perimeter safeguarding system. In this case, the gate may provide protection not only to the operator, but to pedestrian traffic as well. Machine safeguarding can be done by location or distance. One approach to safeguarding by location is shown in this photo. The operator controls may be located at a safe distance from the machine if there is no reason for the operator to tend it by close proximity. Another approach is to locate the machine so that a plant design feature, such as a wall, protects the worker and other personnel. Enclosure walls or fences can also restrict access to machines. Another possible solution is to have dangerous parts located high enough to be out of the normal reach of any worker. Many feeding and ejection methods do not require operators to place their hands in the danger area. In some cases, no operator involvement is necessary after the machine is set up. In other situations, operators can manually feed the stock with the assistance of a feeding mechanism. Properly designed ejection methods do not require operator involvement after the machine starts to function. Using feeding and ejection methods does not, however, eliminate the need for safeguarding. Robots are automated machines that load and unload stock, assemble parts, transfer objects, or perform other tasks with little or no operator involvement. They are best used in high production processes requiring repeated routines where they prevent other hazards to employees. Robots may create hazards themselves, however. If they do, appropriate guards must be used. The most common technique is to use perimeter guarding with interlocked gates. Protective shields do not give complete protection from machine hazards, but do provide some protection from flying particles, splashing cutting oils, or coolants. Holding tools like these are used to place and remove stock in the danger area. Holding tools are not to be used instead of other machine safeguards, but only as a supplement to them. Now that we've looked at some common machine safeguards, let's take a look at a couple of examples of OSHA machine guarding standards. In an abrasive wheel machinery like this, the distance between the wheel periphery and the adjustable tongue must never exceed 1/4 of an inch. OSHA states that a power transmission apparatus like shafting, flywheels, pulleys, belts, chain drives, etc., less than 7 feet from the floor or working platform must be guarded. Now, let's have a quick look at machine safety responsibilities. It is the responsibility of management to ensure all machinery is properly guarded. Supervisors must train employees on specific guard rules in their areas. They must ensure safeguards remain in place and are functional. And supervisors must immediately correct machine guard deficiencies. An employee should not remove guards unless he or she is authorized and unless the machine is properly locked and tagged. And employees should report machine guard problems to supervisors immediately. Finally, employees are not to operate equipment unless guards are properly in place. Under the machine guarding standard, OSHA also describes the training employees are required to have. Employees must receive training on the hazards associated with particular machines, how the safeguards provide protection, and the hazards for which they are intended, how and why to use the safeguards, how and when safeguards can be removed and by whom, and what to do if a safeguard is damaged, missing, or unable to provide adequate protection. Always remember, safeguards are essential for protecting workers from needless and preventable machinery-related injuries. The point of operation, as well as all parts of the machine that move while the machine is working, must be safeguarded. One good rule to remember is, any machine part, function, or process which may cause injury must be safeguarded.